Okay.
Hey guys, the question that often comes at us is why doesn't everybody want to level up their training game? And it's a good question because if you know anything about Hazmat, you know that we give customized training programs and they're specifically designed to unlock your team's potential. So
I'll give you a great example. I'm currently creating a class for a department, and I had to call them to find out the exact equipment that they had so that class could be custom to their equipment, because why am I going to teach something that they don't even have to begin with? So there's your example of customization. You want the latest and greatest in technology in your classroom. We offer that. We're pairing with a whole bunch of different companies to bring actual real meters, actual real equipment into the classroom to give the greatest overall experience possible.
Right. Our instructors are knowledgeable and they're masters at keeping everybody fully engaged. We only partner with the best. And so if you're looking to transform your team's capabilities, don't miss out on training with us. Head on over to thehazmatguys.com/hire us and reserve your spot to start your transformational training experience today. Good morning, afternoon,
day, sir.
Evening. It's twilight.
It is. Is it? I don't know. I honestly haven't actually seen the outside today, so I'm not quite sure what it looks like.
Yeah, could be. I don't know. Maybe. We have a couple of interesting things. Actually, tomorrow, as of this recording, I'm heading on out to the West Coast in San Diego to blow up some batteries. We are coordinating and getting things together. Right now, after I'm done with this show, I'm going to be packing to head out there, and more to be follow up on that soon.
Yep.
There'll be some social media bumps on that, I'm sure.
Yep. We've been asked to come and play at Gillette Stadium.
Yes.
I'm shaving. Am I shaving for that? What is
I just trim it up. You just the whole knock the homeless look down a smidge. Well, it is. No, I don't want to say it. But we do have the next after action report, which is going to be the first Wednesday of every month, at least for right now. But it seems like we're going to have to ramp up a couple more because I don't think we're going to do them fast enough. I think one a month is not enough. So the next one is going to be March 6, 2024, 1930 hours Eastern Standard Time. We're going to have the fabled, benevolent, and just off his modeling tour, Phil McArdle. This is a long format. It is going to be free. There is comments are on, so come and bring some questions and stuff like that. I talked to him this morning. He's bringing a ton of pictures, which I think is a fan favorite right now.
I like pictures. Yeah. I like crowns. I like all those things. I'd love to see some audience members bring some pictures. Like if you've got something of Phil McArdle, that it would be great to surprise him with a random picture and be like, explain what you're doing here.
Yeah, what is that? Is it your pants?
Yeah, it'd be a great way to break some chops.
Yeah, and conferences, we have Walmer, Wisconsin. New England, we're in heavy negotiations with those guys, and also OMRA, which is the Ontario one. Michigan, Cold Zone, South Carolina, Oklahoma, Oregon, I think, and definitely Baltimore. So lots of stuff popping up, and that's only until middle of June or so. So good stuff. But
lots of good things happening. Lots of busy things happening.
Yeah,
we're rocking and rolling. We still have a few things where we're kind of a little biting our teeth because we have a couple projects that we were hoping would have been released, but we are making them better and better and better with every go around. So we will have more information with that in a couple of months. And yeah, so today we're doing some mailbag stuff. We're going to start off. We have slated 2 questions. Okay. I don't know if we're going to get to both questions. One of the questions was a question that somebody had asked Bob, and another question was somebody that asked me. And we'll be very honest with you, we really didn't know the answer when they first asked, not like a solid. And my question, I was like, you're joking me, right? Like I've never heard of this stuff before. So we had to go and do some research, and we were able to kind of give answers. So we're going to give some of those answers out. So the first question that we are going to go into was a question that was posed to Bob. And it's a very interesting question. And when I first heard it, I was like, it's semantics, right? It's kind of one of those like douchebag questions, like absorption, adsorption. Like there's a slight difference, but really people don't, talk the terms. And, when we teach the classes, we talk about definitions, like solid definitions, like what a flammable according to the DOT is, what a flammable according to NFPA is. So this question kind of got us both scratching a little. It is, what is the difference between a flammable gas and an explosive gas?
Yes. There are people, and I've heard this out there where people will, that's one of the things that I laugh about. Some people will throw space between terms to like increase their worth on scenes, but like, oh no, there's a difference between these two. And it's like,
oh yeah,
it's semantic kind of thing.
Yes.
Like I get, but this one, when you start thinking into it a little deeper, I do think there is a little light between these two.
There is. There's enough light between them that it would be like the difference between explosive and deflagration.
Yes.
Like,
yeah, right. Those things have two different numbers.
Right. Like technically you don't care once your head is gone, but there is a tremendous difference between the two. So let's get good.
I will. Sorry. So this is my, when I was asked this, and again, I always try to like, okay, I'm going to shoot from the hip as if I was on the scene, and I'm going to make an argument to see if he'll be like, that's completely wrong. And if I don't even raise eyebrows, then maybe I'm on the right track, but I got to do more research on it. Mm-hmm. That was the big point, is that the difference between an explosive gas and flammable gases, I think, again, is speed of the push of the wave.
Okay.
Of it. So I'm thinking that a flammable gas is going to heat the gas, and that natural expansion of gas will push out.
Right.
As opposed to explosive gas, the timing is a lot, like the delta T is going to be a lot shorter.
A lot shorter.
And the expansion is going to be a lot faster. Yeah.
So let's understand, right, why things first explode and why things are flammable, right? You have a couple of different things going on. We often teach, that the chemical reaction in a flammability thing is driven by the ratio of oxygen to whatever the fuel is. And yes, all that is true. You have to be within the right ranges. But if we were to compare this to, say, a detonation event where you have a detonation and a deflagration, what makes that detonation event happen is that the chemical reaction between one fuel and oxygen and the adjacent fuel and oxygen happens extraordinarily quickly. So as a result of that delta time that you were just talking about, you have energy release. You have the total amount of energy being released is the same. And this was something that I learned in a high school chemistry class, and I was like, wait, what? That doesn't make any sense. The amount of energy released when you burn a candle is the same amount of energy that gets released with the same size, like the same amount of weight of C4 explosive. The only difference is the time. That candle is going to burn at a very slow rate, so it releases its energy over an extraordinarily long period of time. Whereas C4, those reactions from one side to another propagate so quickly that it's as if all that energy is released at once, and since it can't go anywhere, it just expands, and that's where you have this giant kaboom. And flammable gases, it turns out that, you are 100% right in your gut interpretation of what these things were. Yes, it turns out that it has to do with the speed of the reaction, because both types require the right mix of oxygen in the air. Both are going to create heat and have a rapid pressure increase, but it really is the speed of the reaction, and that speed of the reaction then comes into play with what you were saying, which is the speed of the pressure wave coming out. When I just got into hazmat, if you know me, you know I'm not a sports guy. So it was Super Bowl Sunday, and I was bored out of my mind because Super Bowl was on and everybody was upstairs in the kitchen. So I decided to play with making bottle rockets in the actual firehouse, right? Like, not like the fireworks, boom type of fireworks, but literally like right here, a Coke bottle that you drill a hole in one end, you fill it with a rubbing alcohol. And then you cover it, you shake it, you put it down, and you put a match right to this end, which causes an ignition and a fire front starts to form. It's quick, but you can actually see the bottle go from one end to the other. I would say it's maybe a quarter of a second, but you can see that fire front run across. It expands in pressure inside, and that pressure pushes out of the bottle and sends the sucker flying through the firehouse.
Yeah.
I did it a couple times. I was bored. And what does every firefighter think? Well, if that was good, a more flammable is going to be more better. So before I had a really good grasp of vapor pressure and displacement of vapors and stuff, I went, acetone. Acetone is going to get me a better burn because it evaporates quicker. Well, what I didn't realize was in the time it took me to pour some acetylene in, shake it, and put it down, the vapor pressure was so high that it pushed all the oxygen out. When it did this, nothing ignited. All right, so, smart idiot sitting there going, I have no oxygen in the bottle. That must be why this isn't going off.
Pull it back.
Nope. I walked over to the medical oxygen in the rig. And I went and I sprayed it into and I got the oxygen. Well, I put it on the table and I bring the match up to it and the thing just explodes. It doesn't burn. There's no fire front. The whole thing just literally detonates. It booms. So right there is a great example of an explosive gas, right? Because that acetylene at that point, the acetone at that point is explosive because of the speed of the detonation. I wasn't able to get the effect of a slow pressure build and then this thing taking off. It overpressurized the container so quickly that it blew apart. I lost hearing in my ear for 2 days. Everybody came running down to wonder what the hell happened, and that is my bottle in the firehouse story.
The hijinks. I miss it.
I miss it too. So yeah, we can see this. We can see this as something that has the potential to hurt us more than flammable gases. If you've ever been to a propane release, Teeks. You went to Teeks, right?
Hmm?
Okay. Do you remember when they did the massive liquid propane release in the field?
Oh yeah.
Right?
Oh, yeah.
So you see this massive cloud coming, it just floats and it floats and floats, and suddenly it reaches a source of ignition, and you watch the fire front happen. It's quick, but it's still a fire front, and there was no shock wave. If you did something like that with, say, acetylene, not acetone, acetylene, and you built it up in a space and you ignited it, the whole thing would detonate. So there is, in fact, a difference between explosive gas and flammable.
Nice. So, now to the topic at hand.
Yes.
That guy.
Which guy?
Synthetic.
Oh, yeah. You're
gas.
pointing to the title. Yeah. All right. So this one got asked to me, or at least I think I responded on Facebook, because we do. If you send us a question, we absolutely will do what we can to respond. Now, his question was more along the lines of, this is what I got on my meter. We were responding to synthetic natural gas. Why did my meters read this? So I remember when this came in, I was laying in bed and I was like, synthetic natural gas, because he just said SNG. So I was like, what the hell is SNG? So I look it up and it's synthetic natural gas. And I remember thinking, what a freaking oxymoron. Like, synthetic natural, like, what is going on? This doesn't make any sense. I'm like, this can't be real. So I went and I did some research, and it turns out that, holy crap, yes, you can take and you can create synthetic natural gas. Natural gas or methane that is not derived from drilling and piping and things like that. It is a fuel gas that can be produced from fossil sources. It can also be created from renewable energy, and it has become increasingly popular because it is an alternative to conventional natural gas while meeting the energy demands and reducing the environmental impact.
It's interesting. I got to say, because the process to create it, if we separate it off, the gasification of carbon-containing materials such as coal, biomass, waste, That process transforms solid feedstock into a gas through the partial oxidation at high temperatures. That's why this is not a natural thing. They're kind of making it, it's a process.
It's a process. Yeah, it's a chemical
process.
it's a chemical reaction. And the one that was happening in this person's area, they were taking carbon monoxide, hydrogen, and a catalyst and slamming them together, and the resulting output was being pumped out. So all right, so that's a little backstory on SNG. His question was, we had this SNG leak, and our meters were just blowing up. Like, our CO was through the roof. All of our other electrochemical sensors were going nuts. And we don't get this on a natural gas leak. So his question was, what the hell? Now, not having a clue what synthetic natural gas is, but doing what I would have done as resource on a run, I went and learned exactly what we just talked about. And it made total 100% sense why his meters were going crazy. He was getting CO because the product that creates this, you're not going to get 100% turnover, right? If you know anything about chemical reactions, if you've done anything in a lab, your yields are never 100%. So in this pipe...
And sometimes yields roll back and forth.
Right. The arrow goes both ways.
Right.
So, depending on, the different pressures or temperatures or conditions that would favor one chemical reaction versus the other. So I was able to write back and be like, yes, I would 100% expect this, because your hydrogen gives you massive cross sensitivities on all of your electrochemicals. And carbon monoxide as well, right? You're going to get the carbon monoxide hit, but then your H2S, all your other electrochemical sensors are going to go out of whack because of your hydrogen. You're going to get readings on your combustible gas indicator because we're making methane. So you would expect readings on your SNG, not SNG, on your CGI. And you could even get readings on an IR. They didn't have an IR reading, but they could get them.
I wonder if there's any published LELs. I'm sure it's not in the NIOSH or anything like that, but I wonder how much data is published as far as the chemical and physical properties of it from a response standpoint.
Well, it's funny that you say that. So the synthetic natural gas, it is natural gas, right? It is methane, right? Natural gas is mostly methane. So what they're doing in this chemical reaction is they are creating methane. So a methane molecule is going to act as a methane molecule, whether it's derived in a lab or whether it's pumped from the earth or whether it's created in a catalyst reaction. It doesn't know how it was born, and so therefore it is going to react as it normally would. And so we can literally take very similar response measures for an SNG as we would for regular methane as far as detection. I think the one or two things that might concern me would be the levels of CO2. And I know that would be really hard to discern because we have got the hydrogen. So we don't know what part of that CO is going to be the hydrogen and what part is going to be the actual CO, because both are existing in this mixture that's coming out of the pipe.
All right, you confused me because you said CO2 before, but I think you meant CO.
CO, I did. I meant CO. Right. I'm an idiot.
Okay. No, it's cool. I just want to make sure that I was like, wait.
Yeah, carbon monoxide.
Monoxide. But yeah, you know what? That's because you said methane is the majority of natural gas. It's not the completion of natural gas. And so with this, I would assume that there is going to be some other side hustles. Some of the side pieces.
I'm sure some butane is made. I mean, in regular natural gas, there is butane and propane that exist in small quantities. So I would imagine you would have other types of possibilities. So the only thing that I could think of is if, like, what do we know if it's hydrogen or CO? Well, then we come to the whole concept of now we break out a different technology and we see what we can gather. So if I'm getting high levels of CO, I'm going to break out maybe a Draeger tube and see what that parts per million is reading. Because then I could turn around and say, okay, my meter is and this is what I would do like as a quick thing. I don't know how legit this maneuver would be. But I think I would turn around and say, all right, I'm reading 100 parts per million on my electrochemical sensor. I whip out my Draeger tube. It's reading 50 parts per million of CO on my Draeger tube, which means that I can account for 50 parts per million on my hydrogen, which may help give me an indication, a rough indication, granted,
Right.
because you do have to think, well, is there an exponential increase in hydrogen reactivity relative in the electrochemical sensor? I can't really answer that on the fly, but at least it gives you an idea of like, oh, I'm dealing with mostly CO, so if I walk into a place that has a CNG leak and I'm getting a lot of CO, I know that it's CO. Versus, oh man, this is mostly hydrogen and it's going to react just as methane would. It's going to go up and rise. I really don't have to worry about evacuation or calling in medical or having people go to the hospital for high CO. High CO exposure.
Yeah, but even things like, your metal oxide sensor, your sniffer.
Mm-hmm.
That, I'm sure it would work for this because it's a flammable gas.
It's a flammable
like
gas.
Like you said, it doesn't know where it was born from. It's still doing the same thing. And I wonder further, would there be any calibration on the unit itself? Not talking about meters, but like the stove, the heating unit. Like, you know how like when you get a natural gas propane, a barbecue versus a propane, and you got to change the nozzles out because there's different mixture rates.
Made that mistake once.
I wonder if you have to change. Is it a totally different rig? Is it a totally different pressure setup? Regulator setup coming into the house. How is it delivered? Is it in a cylinder, like a propane tank in the back of the house, or are they piping it?
This was piped. It was running through a pipeline.
Oh, wow.
So it seemed like they were taking CNG and, sorry, not CNG, SNG, and they were adding it to the existing infrastructure.
Supplementing,
yes.
So if they're doing that, it has to be so close.
It has to be.
Nozzle switchover is not necessary.
Yeah. I would imagine that we could think of it just like methane, right? We have significant potential flammability and explosive risks now that we know the difference between the two. And we're going to take all those same safety measures as we would for methane. I mean, right, for natural gas, we know that natural gas has an LEL, UEL of 5 and 15 with like a sweet spot right at that 10% mark. So as far as I can tell from my research, it's doing almost the same thing. It's those little byproducts, though, that are screwing up his meters.
You know what? I would bet this is something that me personally, now that I kind of know of it, I'm like, yeah, that's not that big of a deal. Like, there's a name for the process, and I can't remember it off the top of my head, but it's the output of like gas cracking. You get ammonia. There's a specific, not the Haber, it might be the Haber process, where you output pure ammonia, and that's a natural byproduct of the cracking of fuels into the different distillates. I wonder if the juice is worth the squeeze on this one, where this is a natural byproduct. There's no heavy lifting. It's a nice, easy one. Or is this just like the flavor of the day because all the environmentalists are out, and then next week when they go, thank God they're not in power anymore, we can go back to doing it the right way.
Well, it would be interesting for those industrial facilities that pump out CO to be able to do that. And I wonder, in the research I did, it was CO. I don't know if CO2, I mean, with two carbons, with still a single carbon, if they could use that, because that would be an interesting, pull that gas from the air, turn it into methane.
When I say that, guys, there's the reason why I'm saying that is because you have to put a certain amount of energy into things to get bonds to break.
Right.
And, it's not just a haphazard thing. When you're doing it for, in the lab, or we're doing it to like experiment, there's really no cost to it. We're doing it for the effect. But when you're doing it in an industry, every ounce or joule of energy you put it in there is balanced against the sheet of like how much coin can you make for that. And if you're putting in more money than it's worth, the only reason to do it is because you got legislation on your shoulders that say either you do it or you're going to go out of business. So you're like, all right,
I have to.
I'm going to take
Right.
a loss, but I have to. But
Ethanol,
once that's over,
ethanol was a great example of that. It takes more energy to make a gallon of ethanol than the ethanol can produce. So in the long run, ethanol didn't end up being an environmental advantage. It turned out just to be a massive lobby from a particular industry.
right. And we did a whole thing on that. That's what they're now using the ethanol for is to octane boost the fuel. You know what I'm saying? Like,
Right.
you know, and again, we have a great nugget on that. If you're a specialist, you can hear it. But go back and listen to the octane, the calculation of octane that I did. And it was really interesting because it shows you how they use ethanol to kind of goose the system in order to do that. But yeah, the juice ain't worth the squeeze on some of this chemical processes because they're in business to make money.
Yeah.